Hello, everybody. Welcome back to the MCC podcast. My name is Alex Carruthers, and with me is Steve Sheppard.
Hi, everybody.
Steve runs Combined Intelligence, and with the Machine Commons, the Machine Learning Collective, we've teamed up to present Machine Commons Consulting UK. Today, we thought we'd backtrack a little bit. We realized that we're talking mostly to a business audience. Today, we thought we'd actually maybe define a few things. First up, what is AI? Could you think of a more broad term than intelligence and artificial intelligence, no less? Steve, what are we dealing with here? Are we talking about brains in a vat? What's going on?
Well, some of the old scary movies. As you say, intelligence is a very difficult one to define. I'll let people use their own intelligence to understand sort of the basics of human intelligence. Artificial intelligence is, and there are a variety of different definitions, but fundamentally it comes down to us attempting to use technology to simulate human intelligence, whether that's in controlling things, whether that's interpreting things, or in the full Android sense, trying to replicate what humans can do in the diversity that we're capable of doing. It is a challenge, and although we've been working on AI for decades now, it's come up and down in terms of its popularity, but we are making advances and we are getting closer to where we want to be.
So are there different types of intelligence? Are they useful in different ways? Perhaps there's some kind of structural guideline you can give us here.
So where we are now with artificial intelligence, there are a variety of sort of forms of AI. So, a common one is how we use AI for vision. So whether that's images, whether that's videos and so on, how do we interpret pictures that devices take and extract meaning from them? So, the common problem that's often referred to in sort of AI circles is differentiating between a cat and a dog. Human beings, we do it naturally. We as young children, we learn what a cat is, we learn what a dog is, and we can see new versions that we've not seen before, but we can still work out and decide that it's a cat or a dog. That is actually an interesting challenge for technology to work out. And there is an area of AI, sort of computer vision, that is focused around that sort of classification, that sort of understanding, whether in that basic form or the much more complicated scenarios of autonomous vehicles, for example. But that's just one form of AI. You have a similar area around speech and natural language. So that's how do we interpret the spoken word? How do we interpret the written word? And how does that convert from a piece of text, for example, into meaning that can then be interpreted and understood and importantly answered? How does technology hold a conversation with a person, for example, whether that be a chatbot, whether that be a virtual assistant? We have sort of two other categories around planning, scheduling, optimization, expert systems. So how do we apply logic? How do we make decisions? How do we plan? How do we schedule? All that complexity that a human being is able to do is encapsulated in sort of different fields of AI. And one which is sort of overlaps with all the others, which is machine learning. We're going to talk about it a little bit more in a bit more detail. That's the process that we're using to train technology to understand things, to make decisions and so on. And as I say, we'll talk about that a bit more in a bit more detail.
So if I understand you correctly, there's sort of there are things that can be seen, there are things that can be read and written, and these are somewhat different challenges. And is machine learning a technology which necessarily underlies these, or can these domains be completely distinct from machine learning?
Strictly speaking, machine learning is a sub area of AI. It's one set of approaches that we're using to replicate human intelligence. There are other ways of doing that, algorithmic ways that sort of aren't strictly speaking machine learning. But it's probably fair to say the bulk of activity and effort is going in the machine learning space.
Well, I suppose that brings us to the distinction between different types of AI. it sounds like there are some types of AI which are really specific to challenges, and there are other types of AI which sort of try to do many more things. Could you perhaps give us an overview of this distinction and the different types?
There are two classes of AI that we're looking to solve and sort of come up with solutions for. The first, which is where I think most of the focus has been to date, is around what's called artificial narrow intelligence or narrow AI. So it's the ability to apply technology, machine learning, for example, to solve a particular task. So that might be coming up with an AI solution to do facial recognition, or an AI solution for a chatbot capability, or perhaps for detecting anomalies in financial data. It's very much a goal-oriented approach where you train a model and it becomes very good at a particular problem. But that model isn't able to do something else. So you can't train a model, for example, to do facial recognition and then expect it to be able to interpret speech. It's why we call it narrow. It's very focused. It's able to do a very good job at one particular task. Now, the broader goal of certain parts of the AI community is what's called artificial general intelligence, or general AI for short, which is where we're trying to mimic the breadth of human intelligence. So to be able to, for example, learn to solve not just one problem, but multiple diverse problems in a way that a human being does as they grow up. They learn to go from, recognizing faces to being able to walk and to talk, to do complex activities. That ability to be able to have a model or a whole host of series of models, which is quite possibly where it will be, all interconnected to be able to then effectively act like a human being would do, and to be able to be presented with something new that's not been part of the training scenario, and for the technology to then to be able to think, to interpret, to understand, and do something sensible and logical out the back of it, even though it's perhaps never come across that problem. Very much in the same way as humans would do to try and solve a problem. That's being worked on. I think there's quite a bit of debate about how far away we are from that. I think it's probably reasonable to say we're not there yet, and we've got quite a way to go. But if you look at the massive scale computational power that's being looked at by people like Google, for example, there are massive cloud platforms that are trying to get somewhere near to this. But I think if you consider how massive those platforms are compared with the size of the human brain, we get a bit of an impression about how big a challenge it is and how good the human brain is compared to where we are with technology.
That's so interesting. So, if I'm a manager, non-technical, working in manufacturing, what do I need to know here? Am I worried about AGI and the birth of a general intelligence, or am I more sort of focused in the remit of narrow intelligences?
You're very much sort of focused on the narrow AI space at this point. Ultimately, for a manufacturing production line, for example, there are a series of AI solutions that you could apply there. There might be a diversity, so you might have computer vision, for example, to detect anomalies in manufactured product. It might be you've got some machine learning that's processing the data that's coming from machines to optimize production rates. So you might have a diverse set of different types of AI in there, but ultimately each of those components are a series of narrow AI, perhaps with some super AI above it to try and help communicate and optimize and so on, but a long way off the need for general intelligence at this point.
Right. So to make use of these narrow intelligences, it makes sense that managers would therefore need to have a really firm understanding of a very tightly understood and tightly defined problem.
Yes, in the practical world, we understand that AI is complex. And even sort of, if you look at machine learning, there's multiple different algorithms, and each algorithm has lots of parameters that need tuning and optimizing. So for business people, we very much recognise that they should work with expert teams that ideally have a solution that is solving their particular problem or very close to and can be tweaked and adjusted to solve that particular solution. And that's your best way of making full use of technology is bringing the people with the right skills and knowledge to combine with your business knowledge, your understanding of what you want to achieve out, whether it's the manufacturing line, whether that's the finance team and function, whether it's banking, wherever it is, to be able to then sort of plug that into the wider enterprise architecture and use those currently narrow AI capabilities to deliver real value.
But will these specialists and these specialist organizations have narrow AIs that automatically fit my business? Because after all, my business is unique. Every business is a bit different. How do the narrow AIs that are provided on the market match up to the narrow requirements of a specific business problem?
It obviously varies depending on the solution and the nature of the business and so on. In some cases, you will find AI embedded within business applications and used in a fairly generic way that perhaps needs minor tuning to meet a particular operational need within a business. If you're in more of a sort of specialist area and you're wanting to optimize for your particular needs, then you'll have perhaps another layer of adjusting and tweaking, and particularly if you're trying to use your own data that perhaps is different to the data that solution's been trained on historically, to optimize the performance, you'll want to use that data. Ideally, you won't have to start from scratch. There are a lot of, and through the collective, we've got a lot of organizations who have those specialist skills and capabilities, solutions that will get businesses a lot further down the line than starting from scratch.
Right. Okay. So we've talked about the various types of artificial intelligences which can apply to business. We've made a distinction between general AI, which is often the one that you might read about in the news, or humiliating a Go player, or cracking the protein folding problem, or in the case of Sam Harris or Elon Musk, the doomsday predictions of artificial general intelligence basically becoming Skynet and killing everybody. We've made a distinction between that and narrow intelligence. And these are the sorts of intelligences which can be applied to businesses so long as they're married up to business problems in an intelligent and tightly defined way. So perhaps now we can really hone in on what we as the machine learning collective really do deliver or focus on delivering, and what we would argue is the most intelligent form of narrow intelligence, the smartest tools in the toolbox. But there are so many different types of machine learning tools, of algorithms, of approaches, of systems, and there are even more variations in the way that these are delivered in the market. So, Steve, what is machine learning?
Yeah, machine learning is a diverse field. If you consider the various different ways that human beings learn, in the same way in the artificial intelligence world, we have various ways of teaching technology. The terms that you'll quite often come across are supervised learning and unsupervised learning. The fundamental differences are supervised learning is done with what we call labeled data. So we might have a picture, for example. Within that picture, we might have a traffic light. That traffic light might be red, it might be green, and so on. So what we can do is we can label those pictures with a red traffic light as red and those pictures with a green traffic light as green. And then we can teach a model to correctly predict or classify, in this case, I suppose, using the right terms, each image as having a red traffic light or a green traffic light. And if we present enough examples to that, and a diverse set of examples, then we can end up with a model that is quite good at doing that prediction. And what we then typically do is we test that with a set of pictures that that model's never seen before. And that will give us a view of how well that model is able to generalize to be able to do that classification.
A quick question, or a quick clarification there. So supervised learning is when a client has data which can be labeled, is already labeled, or how do they know what types of data they have, or what areas of machine learning might be appropriate to their business?
So ultimately, the labeling of data is actually one of the challenges with supervised learning. In a lot of cases, we do actually have labeled data. So quite often, for example, we're looking at historical data of something that's happened in the past for which we know what the outcome was. So there might be some work within the business context to combine together the historical data that we had gathered with perhaps the outcome or what happened as a result of it and what we consider to be a positive outcome or a negative outcome, for example. And we may have to do that work to label data and bring input and output data, as we would call it, together so that we can train a model to do that. In other scenarios, we might be trying to solve something that actually has not been specifically done before, in which case we might need to try and label side of things, which can be a challenge. Are we in a scenario where we're having to get human beings, for example, to come and label thousands of bits of data? And one of the bits of work that's been done in the industry is there are tools now that have been constructed to help do some of that labeling.
And of course, there are suppliers which focus on data annotation services. So there are experts who use expert tooling who are incredibly proficient and charge in the fractions of cents per labeled image in order to achieve this kind of labeling.
Indeed, another sort of common problem is that if we only have training data that's about 80% accurate, well, there's no way we can train a model to achieve greater performance than 80% if we're already starting, with 20% of our data being incorrect. An interesting one, and sort of probably brings us nicely onto the unsupervised learning example as well, is unsupervised learning, by its definition, is we don't have labels. We're not teaching it to deliver a specific outcome that we already know. It's a range of algorithms that will look at the data and in many cases look to extract patterns. That might be to cluster data together. It might be perhaps to simplify data where we've got a high volume of inputs, for example, that we might want to simplify that into a smaller number. So we're consolidating the information that's held within that data. So it's a range of algorithms that will extract information and sort of cluster things together, perhaps without us having to have labels. An interesting one that sort of brings sort of the two supervised and unsupervised learning together, which is sort of becoming perhaps more of a common approach, is the semi-supervised learning, which sort of brings together the scenario where perhaps we might have a very large amount of data, but only a small proportion of that data is actually labeled. So what we use is we use training techniques that can extract some of those patterns, but then we can label and use some of the labels, some of those patterns and some of those groupings that have been generated through the models to come up with a classification capability, for example. But based on that mix of high volumes of unlabeled with sort of smaller volumes of labeled data, and solving problems that perhaps we couldn't have done previously with either model.
And of course, you don't need to reinvent the wheel every time you do this. There are vast, vast bodies and libraries of pre-labeled data. There is so much pre-trained algorithms available out there that can be tweaked or adapted to whatever business problem that you have. And more often than not, your business problem probably isn't as unique as you might think it is. And chances are that the bulk of a metal sheet detection problem faced in the steel industry has been made open source, or some data set that recognizes different plants is made open source. And more often than not, your supplier will be able to make use of these readily available resources.
Absolutely. And, I think there is a massive community now working on AI. And there are, you know, people working in multiple different fields, not just from an AI algorithm and sort of technology perspective, but in their business application. And it is important for organizations, if you want to get there quickly, is to try and piggyback on a lot of that research that's already done, and if pre-trained models already exist, is to utilize those models. A common one is if we talk chatbots, a simple application. Well, sorry, not really a simple application, but a common scenario, shall we say, of how AI is embedded within solutions. The ability to interpret language is a complex one, and using already available solutions to do that interpretation, but that then perhaps laying on some additional context relevant to that business in terms of the terminology and the product set and so on that business has, that allows you to use, 95% of the problem, which is the natural language bit, and add in that 5% of context to really make that solution work for the business.
I can't actually think of another industry. As you were talking, I was just trying to think of another example of some product or byproduct which has absorbed millions and billions of dollars of R&D funding, like the types of models or algorithms or open source software that is published by these massive institutionally sized organizations, these country sized organizations even, that they're putting so much work into this IP, and then they're publishing it and making a lot of it available to Mr. and Mrs. Joe Blogg's average business to use. And I think maybe this is kind of a core point. If you're a small business not investigating whether or not there are potential AI applications relevant to your business, you really are missing out on what is essentially free R&D. And I think the first thing that, and we've talked about this before, the first thing that any consultancy will do is check out what's already being done for businesses similar to yours in the industry that you're working in. And chances are there are a lot of applications already in place. And so you should get excited, get curious, because there's so much that's ready for you to begin applying to your business almost now. And the time, because this stuff has essentially already been created, fully tuned, researched, and so on. Once it's in many cases, once it's sort of glued up, once the data pipelines are put and installed correctly in your business, you'll see results pretty quickly. It's a relatively quick process. It's not like installing heavy machinery. After all, it's computational. All of this stuff is in the cloud, and so long as your data architectures match up accordingly, then you're going to have no problems from almost day one.
Yeah, and I think ultimately there is an awful lot of investment, as you say, going into this. There are a lot of the very large organisations who are investing to take a lead. Basically, there's a lot of competition going on in the AI world for organisations to be at the forefront and to be able to demonstrate those capabilities. And part of that is bringing clients into the mix to start to use their capabilities. And yet, a lot of it's sort of been made available. Some of it's free, some of it's, subscription services and so on. And some of it obviously is specialist paid for solutions. So you've got that combination, but that, doesn't, stop organizations, smaller organizations included, making use of this. Because now with our cloud architecture and cloud infrastructure and so on, everything is remotely available as well. We've lost all that need to install things locally and all that sort of complexity. It's just available, just needs plugging in to make use of it.
Would it be fair to say that much of the stuff that we've just talked about, the large organizations have done, that's kind of in the domain of reinforcement learning?
Yeah, so reinforcement learning sort of as another category of machine learning, it's the one where arguably you could say that human beings do a lot of reinforcement learning as the way we learn, particularly if you're a child, but we do this for our pets, to be honest, as well. Reinforcement learning is basically saying, okay, if I reward my dog, for example, for doing something that I want, and perhaps I tell it off for doing something that I don't want it to do, and over time, that dog will learn, because perhaps it gets a nice treat, to do the thing that we want it to do more often than not. And that is sort of a mechanism that is quite often, and I think a lot of it came in through gaming-based AI. Alex, I think you mentioned AlphaGo, and Google, and a lot of its work it's done to use machine learning to play games, whether that's traditional board games or whether that's RPG, role playing games. Basically, we can set AI up to attempt to play a game, and obviously the outcome is to win the game. And if let the model go through what potentially is millions of different scenarios of how to play the game, it can learn to get good at that game. The interesting thing with AlphaGo, which is back to the sort of the general intelligence side of things, and where Google have sort of got with it, is they've managed to produce a platform that can play multiple different types, and it can be applied to other games and fairly quickly get good at those other games. So it's sort of being able to generalize on how to play, a certain range of sort of types of games and applications, and they'll sort of be spinning that to non-game type scenarios as well. So it's getting close to general AI, but it's in a common sort of problem set, shall we say, at this point.
Yeah, so this is obviously the remit of machine learning, which requires a huge amount of compute time, and anything which can be framed within decision sets and reward schema can essentially be applied via, or can be addressed by reinforcement learning. But it's interesting. I'm sort of looking at these four categories that we've just covered: the supervised, the unsupervised, the semi supervised, the combination of both, and the reinforcement learning. The boutique consultancy is able. I mean, they're across this. They're going to be stitching in a variety of different machine learning approaches and methodologies into any solution, even if it's a simple recognize a type of product, categorize the brand, read the writing, read the price next to it, and then save that in a certain place using RPA. There are almost any solution is going to include a variety of different approaches that we've just covered now.
Yeah, and I think that's you raise an important point. When you have an AI solution, that doesn't necessarily mean you've got uh, pure AI in the middle and it's just supervised learning. It could be a range of models that are combining together to produce the outcome that the business needs. It could be combined with other technologies. We didn't really talk about it at the start, but AI is closely related to a range of other areas, whether that's robotic process automation or intelligent process automation. If you combine AI with that, whether it's augmented analytics, whether it's virtual reality, autonomous vehicles, smart devices, IoT devices, and so on, all of those are closely related to the AI field, can use the benefits and capabilities AI does, the combination of other technologies and cloud and all that sort of stuff, bringing all that together to really get benefit out of technology, of which AI is an increasingly important part of it.
If you heard one thing, it's free R&D, folks. So get curious, get in touch if you've got any questions, or if you'd like to begin your journey in AI. And especially if you're in the UK, Steve and his team offering free inspiration workshops. So begin your journey.
Thank you, everybody.